Hello everyone, in this video I am going to explain how we can construct a binary tree by using traversal methods. We'll start by understanding what a binary tree is, how the pre-order and in-order traversals are work, and finally we'll get some real example to reconstruct binary tree step by step. So let's begin. Firstly, we'll take some idea about binary tree. A binary tree is a hierarchical data structure where each node can have at most two children. These children are called the left child and the right child. So as you can see here, A is the root node of the tree and the nodes B and C are the left and right children of A. Nodes D and E are children of B where the B becomes the root of left subtree. And the F and G are the children of C, where the C is the root of the right subtree. This kind of structure is very common in data structures, databases and algorithms. So now that we understand what a binary tree looks like, let's see how we can visit all nodes in a tree by using traversal methods. To visit all nodes in a binary tree, we use a method called tree traversal. A tree traversal means visiting each node exactly once but in a specific order. Let's start with pre-order traversal. In pre-order traversal, nodes are visited in the order root, left child and right child. So let's start from the root node, whereas the A, then goes to the left child B, then goes to the left child of left subtree D, then goes to the right child of the left subtree E. Then we go on to create the right subtree of this tree from the root of the right subtree C, and also it is the right child of the root A. Then we go to the left child of the right subtree F. Finally, we goes to the right child of the right subtree G. Then we look into the in-order traversal. In in-order traversal, nodes are visited in the order left, root and right child. Let's start to create a tree from the left child of left subtree D, then move into the root of the left subtree B, then goes to the right child of the left subtree E, then move to the main root of this tree A, and then goes to the left child of the right subtree F, then goes to the C where it becomes the root of the right subtree and it also the right child of the root A, and finally we move into the right child of the right subtree G. Now I am going to look into post-order traversal. In this traversal, nodes are visited in the order left, right and root. First, we start the root from the left child of the left subtree. As you can see, the left child is D. Then we move to the right child of the left subtree E. Then moves to the root of the left subtree B. Then we have to create the right subtree of the tree from the left child F, then moves to the right child G, and then moves to the C, which is the root of the right subtree, and finally we can move to the root of the whole tree. We already learned how to construct a binary tree using pre-order and in-order traversals. So now we understand how pre-order and in-order traversals are work. Let's use these traversals to construct a binary tree using a real example. Before we start, remember just two important rules. In pre-order traversal, the first element is always be the root. In in-order traversals, the element to the left of the root forms the left subtree and the elements to the right forms the right subtree. Using only these two rules, we can build the entire tree. Now let's take a real example. As you can see, there is a two traversals named as pre-order traversal and in-order traversals. Using these traversals, I'll now reconstruct the original binary tree. As the first steps, I'll start with the pre-order traversal. The first element in pre-order traversal is always be the root. So here the root node is 1. So I place 1 at the top of the slide. Next, I locate 1 in order traversal. So now the all values on the left forms the left subtree, and all values on the right forms the right subtree. Now let's move into the pre-order traversal again. The first pre-order element is 2, so 2 becomes the left child of 1. Now I'll split in node at 2. Next I'll move the pre-order element traversal again, and the next pre-order element is 4, so the 4 becomes the left child of 2. Now I splitting in node at 4. Now I move to the pre-order traversal again, and the next pre-order value is 8. Since 8 has no elements on either side, so the 8 is a leaf node. Now I move to the right subtree of 4. The next pre-order element is 9. So I split in the in order at 9. So 8 becomes the 10 becomes the left child of 9, and the 11 becomes the right child of the 9. Finally, I return to the node 2. The remaining node is 5, as you can see. So the 5 becomes the right child of 2, and it is the leaf node. Now I am going to construct the right subtree using traversals. The first pre-order element is 3, so the 3 becomes the right child of root 1. Now I split in the in node at 3, so the 6 becomes the left child of 3, and the 7 becomes the right child of 3. Now let's look at the final constructed binary tree. So this tree is built only using pre-order and in-order traversals, as you can see. Now I am going to construct a tree by using pre-order and post-order traversals. Before we start, you have to remember the pre-order and post-order traversals alone are not enough to build a binary tree. This only works for full binary trees, which every node has either 0 or 2 children. This is why pre-order and post-order combination can work here. Now you can see there is a pre-order and post-order traversals. We use this example to construct a tree step by step. In pre-order traversal, the first element is always the root. So here the root becomes A. So now the element after the root in pre-order is the root of the subtree. Here that's a B. Now in post-order, nodes are visited left, right and root. So all nodes before B in post-order belong to the left subtree. Left subtree nodes are D, E and B. Now we can separate left and right subtrees using pre-order and post-order. We repeat the same logic for each subtree. Left subtree root B has children D and E, and right subtree root C has children F and G. And here's the fully constructed binary tree. Because this is fully binary tree, pre-order and post-order were enough. But without this condition, the tree cannot be uniquely built. Now I'm going to end my video. In this video, we learn what a binary tree is and how tree traversals work. Focusing on pre-order and in-order traversals, we saw how pre-order helps to identify the root nodes while the in-order defines the left and right subtree structure, allowing us to construct a binary tree step by step using real example. We also noted that a binary tree can be constructed using pre-order and post-order traversals only when the tree is a fully binary tree. These concepts are fundamental in data structures and are widely used in real-world applications such as compilers, databases, and file systems. If this video helped you to understand binary tree construction, please like, share, and subscribe for more clear and simple tutorials. Thank you.